So let me go ahead and take you through the new functionality in LibPressioPredict. So at a high level, there is now a thing called a scheme. Okay. So here is a creation of a scheme called mock, which is used for testing. You can combine that with a compressor. So in this case, we have a mock compressor, which is used for testing. Then we're going to need a couple other things. We'll need some input data, which is just a Pressio data object that you want to do your predictions on. You'll need some scratch space potentially for compressed data, if that happens to be needed to compute your particular metrics. Same thing with output data space, if you happen to need those to compute your particular metric. Those are there. Then you're going to have features and predicted labels. You can get from any scheme the number of labels that it expects to produce by using this scheme getLabelIDs.size. And then once you have that, you can get a predictor, which translates the metric IDs to the appropriate metrics. And then from there, you can either, if training is required, you can compute the actual labels. And then you can call this scheme get features and labels. You pass it the compressor that you want to do the prediction on. You pass the settings that you changed to represent this particular prediction. So for example, if you're changing Pressio abs is the thing that you're changing, it's over the course of a search, you would have Pressio abs in this settings object. I'll show you what that looks like in a second. Okay. The input data, the compressed data, and the output data locations. And then it takes a cache object, which I'll talk about in a second. So first, let's look at what settings look like. So if you are doing a brand new prediction and you haven't done anything in the cache before, you can use this predictors :all to indicate that you want to collect all metrics associated with this particular prediction scheme, except for those that are required for training. Those are always collected separately. If you want to get everything, including training labels, then you use this syntax where you add this predictors :training. And basically, this is just a struct with the thing that you're going to pass to that settings object right here. And I'll kind of take all of this code out of this large test case, and I'll write kind of a clean code that shows you exactly what to do. I just want to start with this test case code to kind of show you a high level of what to expect. Okay, so now that we're looking back at this test scheme, after you've done this, the scheme can tell you whether or not training is required for that scheme. So the ones that are implemented right now do not require training. So what you would do is we would be in this branch. So in this branch, you just need to collect the features in this particular case, because you don't need the actual labels.
Yeah, okay.
And then you call predictor predict with features and the predicted labels. And what this will do is this will populate predicted labels with the features associated with it. And then this is just a Pressio data object. So if, for example, you want the compression ratio out of this, these are stored in the order that getLabelIDs produces them. So if you wanted to say compression ratio, and compression ratio happened to be the first label ID, what you could do is you could do double star PTR equals predicted labels dot data. And then we need to cast this to a double star. It's all of the features are always assumed to be double precision values. So that's always a safe operation. We don't have to necessarily check that that's the case. And then it's going to assume a 2D structure. So each row in this represents a single prediction. So if you provided 2 rows of features in predict, you'll get 2 rows of output. If you provide just a vector, a 1D thing, you'll get a 1D thing back out. So then to find the index of that, you can do scheme arrow get label IDs. And then I believe that requires, okay, and that returns a std vector of std string. And then you can kind of do a lookup in this vector for an index that corresponds to wherever the metric that you care about. In the case of all of the metrics that I've done so far, you don't have to go through this step because there's only one thing, so you can just do PTR of 0.
So really, there's only compression ratio prediction, right?
Yeah, because right now there's only compression ratio prediction. A few of the newer metrics that I haven't integrated yet do other kinds of prediction, and the code is designed to support other kinds of prediction beyond just compression ratio prediction. But for all of the schemes that exist today, you can just do PTR of 0.
Okay.
And it will grab out the compression ratio if you need to inspect that manually.
Okay.
Additionally, you can kind of ask LibPressio to predict to collect some metrics or compute some metrics for you. Auto LibPressio or predictor quality scorer. And then there's one called med APE, which is the median absolute percentage error. This is one of the most common metrics used for evaluating these scores.
Okay.
Scorer. And that's not working because I don't have this header in here. So predict.
The median average percentage error is like the way to assess the quality of the prediction, right?
Yes.
Okay.
You could potentially have other ones, but that's the one that I have for now.
Yeah, right now I'm using like average prediction error, just like that. But yeah, sure. Okay.
Yeah. So then this needs 2 sets of things. It needs the predicted labels and the actual labels.
Okay.
And since I don't have the scope quite right, this doesn't work, but you get
yeah. It's something like that. Sure.
And then once you've run this, this score.score or arrow score, you'll do scorer get metrics results.
Okay.
And you can just print that the way that you.
A double value. Yeah. Okay.
Okay. So at a high level, that's the new functionality that got added to LibPressioPredict.
Okay, sounds good. So how do I? Okay, so I have so from the high level, I have a few questions. So first of all, how do I specify what kind of predictor to use in the first place?
Yeah. So I'm just going to go to a temporary directory. I'm going to make a new project.
Right.
So let's kind of write this from scratch. So we're going to say evaluation.cc.
Okay.
And then we're going to create a CMakeLists.txt. CMake required version 3.20, and then project prediction eval, add executable, evaluation.cc. We're going to need a couple of LibPressio packages, so we'll just say find package, LibPressio tools required. And then we're going to say we want LibPressioPredict, and that'll be required.
Right.
We'll start with those two. Target link libraries, evaluation, private, LibPressio tools. And then we can come in here and LibPressio tools, we want LibPressio meta from that. And then from LibPressio predict, we want LibPressio predict. Okay. And then we want our IDE to give us some things. So we're going to say set CMake export compile commands on int main. And we'll just go ahead and include LibPressio. Actually, do this first. CMake -s dot -e build. CMake -build. Okay. So now if we pound include LibPress.
So a quick question. So if we install LibPressioPredict, does that mean we also installed other predictors as well?
So good question. So I'll talk about that in just a second. So the high level thing that we want is this scheme header, which I believe is included like this. Because you might want to know what schemes are available. So we're going to get our scheme repository by doing scheme plugins. And we're going to go ahead and add a using namespace LibPressioPredict. So the first thing we could do a for auto I in plugins. So with that will let us loop over all of our available scheme plugins. And then we can say I.first. And then for that, we need to screen. And we're also going to go ahead and grab LibPressio exe.
So what do you mean by scheme? Does it mean a kind of predictor?
Yeah, so it's a whole prediction scheme. So it includes both the metrics that you need in order to compute it. It includes the predictor, which then relates those metrics to how you do the prediction. It's kind of a holistic, high-level interface.
Got it.
So if we do CMake build evaluation, these are the four that have been wired up so far.
Okay. So sets and okay, I see. Okay.
So we can go from here and we can build one of these. So let's go ahead and get a CN or a CN scheme. So we can say plugins.build CN 2022. Okay. So once we've built this, we can get its options just like any other LibPressio thing. And we can go ahead and print that. Okay, so we see that this particular method takes Pressio abs, it takes a block size, and it takes an error bound. The block size of 0 happens to be special. It defaults to whatever the data size is. Okay, so now we need some data. So let's go ahead and pull in some data. So we'll do IO plugins. Build POSIX. Actually, it's not POSIX. Let's do HDF5. Auto HDF5. Invalid template application size out to incomplete type. Oh, okay. That's because we need to bring in IO.h.
IO loader or something. Yeah.
Yeah. So we can then say IO read.
The HDF file.
Null pointer.
Okay.
HDF, and then set options. So we can come in here and set the IO path. Our Underwood get data sets. I happen to know that Nix.
Yeah.
Get data sets. It's lowercase Nix. And then we can grab this. And then I happen to know HDF5 data set.
Better density.
I think it's called
The native field slash.
Yeah, it's native field slash baryon density. Okay. And this creates a Pressio data we'll call input.
Okay.
Okay. So now that we have this data, we probably want to do some predictions using CN's method. So first, let's just confirm that we read in the data correctly. So if input,
did you specify the dimension?
We actually don't have to.
Oh, okay.
So if input is null pointer, we'll do IO error message. Actually, it's HDF. And L. Exit 1. I can stop typing so quickly.
I'm gonna follow your video later. I cannot type as fast as you can.
Okay, so it loaded the data correctly. So the next thing that we probably want to do is we probably want to configure the scheme. So we can come in here and configure the scheme. So let's just do that here. So CN scheme set options. So what's an option that we want to set here? So we probably want to set Pressio abs. What do we want to set it to?
So 0.01 or something, right?
Okay, so 1E-3.
Yeah.
Yeah. Do we want to set any of the other options for that? So we could also set the block size or the, yeah, let's just set.
I would say using the default version for everything else. Yeah.
Yeah. Okay. So now we can go ahead and get the predictor. Okay. So auto predictor equals scheme CN scheme get predictor. Okay, that needs a compressor. So we'll go up here compressor. So we need a compressor, but in order to do that, we need to build a compressor. So we'll say auto comp equals compressor plugins dot build is E3. So that's one of the ones compatible with that scheme. And we need to do SEO compressor here apparently. Okay, so now that we have the predictor, we need to actually run and collect the metrics. So we'll say cin scheme, and then we want to get features. Okay, so what are the arguments that we need to features? We need a compressor, we need the invalidations, the input, output, and compressed, and the cache. So for the compressor, we'll pass the compressor. For the invalidations.
What is the invalidation?
Yeah, so that's the things that we're changing for this particular call to this. So Pressio abs is one of those things that happens to be an invalidation. So I'm going to delete. I'm going to take this Pressio options settings.
Okay.
And then we can come in here, settings, and then we have the input object we need, but it's a pointer, so we dereference it. We need to go ahead and create some output storage space. So we'll go ahead and do that here. So we'll say Pressio data compressed is equal to Pressio data empty, Pressio byte dtype, that so, and then we'll need the output data. So we go ahead and do that. In newer versions of LibPressio, we can just do this.
Okay.
And it will clone the shape, but not populate with any data. And then we need compressed and output. And then we need a cache. Currently, we have nothing in our cache.
Okay.
And what this is going to return is a Pressio data. So this will be the features. Okay. So then we need labels. And for that, we need to figure out what size they are. So we'll say Pressio data. And I'm going to add some convenience methods eventually to make this part easier. Owning Pressio double dtype, cin scheme, get labels, IDs. Yeah, so get label IDs, dot size. It expects this to be a vector, so we'll wrap it in curly braces. And then we can do predictor, predict, and then features, labels. Okay. And at that point, we've done a prediction.
Okay.
So we can go ahead and print out the prediction. So
I forgot if sense work involves sampling doing prediction. If it does, so this will be the time that sampling carry out first, and then evaluation based on the sampling data, right?
Yep.
Okay. Then in this case, is it and I also noticed that I think Khan's work also maybe some other prediction scheme also involves maybe like machine learning training and using simpler data. I'm wondering if it is possible to only draw inference using the LibPressioPredict if I were to have a sample data somewhere hosted.
Yes. So what you would do for that is so here we got the prediction for this particular.
It's 5, right? 5.56.
Yep.
Okay.
Yep. So if we wanted to, in addition to what we've done here, we can ask the CN scheme if training is required for this compressor.
Okay.
Okay, I'm going to put this before get features,
Okay.
just to help this move a little faster. Cancel. I forgot to flush.
Oh.
So
okay.
Training is not required for this particular scheme, and that's actually going to be true of all of the compressors that are supported right now.
Right. So I don't see any predictors listed here require the training, right?
Yes. So technically, Hassan's method,
right,
which is FXRZ, when it is added, it will require training. And then I'm also going to add, there's a student, Alex Polos at Clemson. She has several methods we're going to add. There's a method from David Krasowska and Arkadipavika Ganguly, which we want to add. Those also require training.
Yeah. But the 4 listed here,
but the 4 listed here do not require it.
Okay.
Right.
So at a high level, this is how the new code works.
Okay. Sorry, about the sample data thing, can I specify the pre-sample data into the prediction? Because otherwise it's gonna be a little bit difficult for us to compare the time versus repeated work, because we only do inference here, but other work need to do sampling in the memory at real time. So that's a little bit different.
So you're saying that you don't want to pass a whole buffer. You want to control the sampling time yourself. Is that what you're saying?
Yeah, something like that.
So,
or if
these prediction metrics are pretty tied to their sampling method.
Okay. So you are saying that they sample differently in different ways.
Yeah. So I wouldn't recommend trying to separate those.
Okay. So then what about maybe the time metrics? When you measure the prediction time, can you exclude the time of sampling in any way?
Yeah. So what we could do is, in addition to doing this, we can ask for so the part that's expensive is the part that's computing the metrics. That's this call right here on line 45.
Yeah, that's the sampling part, right? I suppose.
Yeah.
Okay.
So if you just want to compute the inference time, the inference time is just this line right here.
Oh, I see. Predict. Okay.
Yeah.
Yeah, that will work. Yeah, okay, that makes sense. Okay.
So at a high level, that's how this works.
Okay. So on the scope of this prediction, Khan's work using support SZ3 ZIP, San's work support SZ3, and I believe Tao's work support SZ2 and ZIP, right?
Yes.
Okay, so maybe that's all the comparison we can draw from this for this paper. Then okay.
Yeah. And Alex's method has a few more, but so Alex's method, Tao, or so if I get the training ones, the training based ones completed and integrated, those are extendable to several more compressors. So Hassan's work will work with any ESI based compressor, I believe. Alex's method has been shown to even work with things like Spur or T-Thresh.
Okay.
Same thing with Arca's method and that. So I'm working to include those. Those will be in probably the next release after this. Which I'm expecting will be in the next 2 days or so, because Alex needs some of this for her SC paper as well.
Okay, so bottom line is we can use this in our paper for comparison. The future ones can be, in the future.
Yeah.
Yeah. Okay. So, okay, I may have a few more questions, but okay. So essentially, I can basically, so they will just do sampling in the memory and draw comparison from that.
Yeah. If you needed like finer grain timings or something like that, we can add timings of like individual metrics to.
Oh no, that's fine. I just want to make sure we are drawing a fair comparison between different methods, because we are only doing inference using AI, and here if you wanted to include sampling time, that's a little bit different. So yeah.
Yeah.
Okay, sounds good actually.
I have a quick question. So, do we need to install the, for example, Khan's method and San's method separately?
Yeah, so that's the next good question. So if we say SPAC info LibPressio predict, you'll see that there's a bunch of variants on here. So opt is a new feature that you shouldn't touch. But if you look here are various methods. So Raman's method requires Python, but CN and Con both require to be turned on. So you would say plus Con 2023 or plus CN 2022 to turn on those, and that would then.
Okay. So these are more F2. Okay, I see.
Yeah, and the reason for that is these require some additional dependencies, and it should be that SPAC will ensure that you get compatible versions of LibPressioPredict and the corresponding implementation of the compressor so that they work together.
Yeah, I see.
Yeah, and the way that you would specify that is it would be like LibPressioPredict plus Con 2023, for example.
Okay. I'm sorry, what's the difference between Con's 2023? Oh, so the 2023 include both SC and ZP, right?
Yes.
And ZP. Okay. Plus. Okay. Now, did you mention that currently the FXRZ are supported or not supported right now?
So, kind of.
I think FXRZ is Raymond 2023, right?
Yeah. So it's kind of supported. So you notice that it didn't get outputted in this list of supported modules. So if we're going to come up here, auto m equals metrics plugins for auto I in m if I dot first contains
Oh, by the way, I just noticed that Tao's work is not included in the win of spec predict.
Yes, so that's because Tao's method does not require any additional dependencies.
Oh, so okay, so it's kind of built-in.
Yep.
Okay.
Okay. So you see how there's this metric plugin for Ramen 2023?
Uh-huh.
This metrics plugin will compute all of the prediction pieces that you need in order to train Ramen's method.
Sorry, can you say it again?
So if you look at Ramen's method, there's a bunch of predictor there's a bunch of metrics that you need to compute from a data set that you then feed into a machine learning model.
Okay.
So if you
So I have to pre-calculate those.
Yeah, so you can calculate them using this metrics plugin.
Okay.
But if you do that, the machine learning piece that assembles them together is not yet added to this code.
Then in this case, is it possible to use FXRZ to search the corresponding error bound from?
No. So the reason why, so you can use, if you want to predict a single compression ratio, like you want to collect the metrics and then predict the same compression ratio target, that will work. And because of how the machine learning stuff works inside of Ramen's method, if you provide an exactly on point value, like for example, the exact error bound that corresponds to the configuration that you want,
right,
then it will do the right thing.
okay.
And it will just return that exact value. It's just not implemented fully yet.
So in fact, Jingzhen, as I mentioned previously, Ramen's method actually is to predict the corresponding error bound based on the target compression ratio.
Right.
Right. Essentially, it is also trying to build a kind of relationship between the error bound and the compression ratio.
Yes. So my
right.
question
So
is actually if we can compare with that by drawing from a target compression ratio, how long does it take for us to work, and how long does it take a Ramen's work to figure out the right corresponding error bound based on a target compression ratio, for example?
I think Ramen's method will be faster because it build the model to directly.
We only do inference,
right.
right? So maybe we can be faster, but I'm not sure if that's achievable within LibPressioPredict.
Yeah.
So the short answer is, once I wrap it with the scheme plugin,
okay,
that puts it into this first list instead of the second list. Once that is complete, it'll have the Python piece that it needs, and then you can just load a pre-trained model for FXRZ.
Okay.
And then just do a whole bunch of inferences, and those will be super cheap.
Okay.
But
we don't have it right now, right? So that's fine. I mean, maybe this can be a
you showed us, for example, for the FXRZ, there are some lines regarding the training, right? So, so in fact, when we perform the experiments regarding FXRZ, we want to train the FXRZ using some training data set, but test it using another set of the data, right?
Yep.
Right. So, my question is that your code support that?
Yes. So what you would want to do is so going back to that testing code, you can call get features to get the inputs that you need for FXRZ for a new data set. And then before you do this, you would say predictor fit
for training
with the training information. So it would be features actual labels, and you could load that. Alternatively, there will be a way to do it with set options, where you'll do something like predictors model.
So it's a pre-trained model.
And pass a pre-trained model.
Okay.
But that code isn't ready yet, which is why I haven't uploaded the scheme plugin yet.
Okay, so I see. If we want to test the FXRZ, the current code support that the training data set, we train the model using the training data set and or using the testing data set and then test the model with the same data set, right?
Yep.
Okay.
And you can save the training data set and training labels to a file very easily using the Pressio.io routines. So you can just write out the features and the labels that you need to a file to ensure that you have those.
I see.
Okay.